Hi, everyone. I'm really excited to tell you about my improved germination drought-tolerant cover crop mix. But first, I need to share some statistics with you. In a May 2022 report, the UN shared that this year alone, more than 2.3 billion people live in areas affected by drought. And each year, almost 30 million acres is lost to drought and desertification. They estimate that by 2050, drought may affect over 3/4 of the world's population. This, of course, affects agriculture in myriad ways, perhaps most noticeably in soil moisture content. In a 2016 study by Tribula et al., germination decreased for all cover crops under lower base water potentials. Poor seedling germination has implications for both commodity crop and cover crop production, but cover crop systems have greater potential for increased soil water content and soil water infiltration, and these improvements can help keep marginal ag lands in production. So we need to be pursuing ideas that can make cover crops successful and sustainable in arid environments. Current solutions to cover cropping in dry years are primarily management focused, like delayed planting, using supplemental irrigation, or increasing seed to soil contact with tillage or seed drills. All of these methods have pros and cons, and some may not be accessible to all growers. Another approach to cover cropping in dry years is to use drought-tolerant seed mixes. However, drought tolerance and the ability to germinate in a drought are two different properties. The Tribula et al. Study found a positive and significant correlation between seed weight and base water potential required for germination. And they also found that plants in the Poaceae, Brassicaceae, and Asteraceae families required the least amount of water for germination. One recent technological advance offers a promising solution. Researchers from MIT and Morocco are currently in trials to create an easy-to-manufacture seed coating that maximizes moisture absorption and nutrient retention and resists seed desiccation. Early results are positive, and one big advantage of this coating is that it is easy to manufacture using readily available, low-cost materials. My innovation combines drought-tolerant cover crop species with low seed weights that germinate under low water potential conditions with this improved moisture absorbent coating. In order to bring this incredibly useful tool to farmers, we first need to trial different mixes with the seed coating in order to see which mix works the best and under what conditions. Once a mix is selected, we plan to partner with a seed company for bulk seed, packaging, and distributing. However, we plan to manufacture the coating internally because that would potentially enable us to partner with other seed companies outside of our immediate region in the future for a wider distribution network. This is important because my initial customer discovery process found that interest was mostly in dry or drought years. In other words, in an average rainfall year, customers are less interested in paying an estimated 20 to 25% more for the improved coated seed mix. This is understandable, and we need to build the expectation into our business plan. Expanding the geographic range of our product is a means of normalizing profit between dry and normal years. There's a lot more that could be said about the characteristics of the coating and the manufacturing facility, but the first step in this process is to fund field trials. For this, I am proposing a 4-year exploratory trial to determine ideal species composition and coating methods under different annual conditions of moisture and temperature. I hope you will consider this innovation for funding as we work together towards a more resilient future for agriculture. Thank you.